We hear about artificial intelligence literally everywhere. But have you ever stopped to wonder how it actually learns? Really learns? Well, it's not magic, it's a process. And today, we're going to pull back the curtain and train a digital brain from the ground up, step by step. So that's the big question, right? How does a machine learn to think? It seems so complex, so sci-fi. But the truth is, it's a surprisingly logical process. So let's forget about the Hollywood movies for a few minutes and break down how a machine goes from being a complete blank slate to making some seriously intelligent predictions. To get how an AI learns, first we've got to meet our student. And forget all the complex code for a second. Just picture this, a digital brain. Now, the technical term for it is a neural network, and it's the foundation for pretty much all modern AI. This is our blank canvas, all ready for its first day of school. So this digital brain, it's built out of these really simple little things called neurons. They're just tiny units that do a bit of math, and they're all organized into layers. And hey, when you hear that term deep learning, don't let it intimidate you. It's not as complicated as it sounds. It just means there are a lot of these layers, all stacked together, creating this really powerful network that's ready to soak up information. Okay, so we have our digital brain, but an empty brain is pretty useless, right? It needs knowledge. And for an AI, that knowledge comes in one form, data. You can think of it as the curriculum, all the textbooks, the lectures, the homework that our digital student is about to dive into. And let me tell you, this brain is not a picky eater. It can learn from almost anything we can turn into numbers. You got images, it sees a grid of pixels. You got text, it can read through customer reviews or news articles. It'll happily crunch through spreadsheets full of numbers, or even listen to the raw waveforms of an audio file. But you can't just dump a bunch of raw information into the brain and hope for the best. Nope. Just like you'd chop up some vegetables before you start cooking, data has to be prepared. We call this preprocessing. And it's a super important step where we clean up and organize all that data into a format that our neural network can actually understand and, well, digest. All right, our brain has its study materials. Now the real learning begins. And the very first thing it does is actually pretty simple. It just makes a guess. This is called the forward pass. It's the moment the brain sees a piece of data for the very first time and takes a total shot in the dark. The whole journey is just a straight line. So the data enters the first layer of neurons, then it zips through all those hidden layers in the middle, and each little neuron does a tiny bit of math before passing its result to the next one in line. And finally, boom, it reaches the end, and that last layer spits out a prediction. Now let's be real. This first guess is almost guaranteed to be wrong. Hilariously wrong, probably. And that is perfectly okay. The brain is completely untrained. It's like a baby just babbling sounds. The guess itself isn't what's important here. What happens next? That's where the magic really begins. Okay, this right here is the most critical part of the entire process. This is where the brain gets to compare its wild guess to the actual right answer and has its big aha moment. It's that instant it realizes, oops, I made a mistake, and then figures out how to learn from it. Let's make this super simple. We show our digital brain a picture of a cat. After its forward pass, it confidently announces, dog. Close, but no, it's wrong. So now we need a way to tell the brain not just that it was wrong, but how wrong it was. We do that with something called a loss function. Honestly, you can just think of it as a teacher grading a test. It's just a math formula that calculates an error score. If the guess was way, way off, it gets a high score. If it was pretty close, it gets a nice low score. Simple as that. So, with that error score in hand, the brain does its most brilliant move. It's called back propagation. This is where it basically plays detective. It sends that error score backward through the entire network, tracing the mistake all the way back to find out exactly which connections were the biggest culprits for the wrong answer. This is the secret sauce that makes all of this learning possible. So once the brain finds the troublemakers, it makes a tiny adjustment. It just tweaks the strength of those connections that led to the mistake, nudging them in the right direction. It's basically telling itself, okay, that pathway was wrong. Let's make it a little bit weaker for the next try. But hey, learning isn't a one-time thing, right? You don't learn to ride a bike by falling off just once. You get back on and you try again and again. AI is exactly the same. It learns through this continuous cycle of practice and getting better, and we call that the training loop. In the AI world, we've got a special name for one full practice round. It's called an epoch. An epoch is just when our digital brain has had a chance to look at every single piece of data in its curriculum one time. So after that very first practice round, Epoch 1, the error score is pretty high, 0.89. The brain is still making a ton of mistakes, but hey, it's just getting started. But check this out. After a bit more practice, by Epoch 10, the error score has dropped a lot. Every single mistake has made the brain just a little bit smarter, and its guesses are getting way more accurate. Now let's fast forward to Epoch 100. Whoa, look at that score. It's incredibly low. The brain has seen all the data enough times that it's starting to really get the underlying patterns. Its predictions are now super reliable. It has learned. And that simple loop, guess, check, correct. That is the engine of AI learning. It doesn't happen all at once. It happens over thousands, sometimes millions of these tiny little cycles, with the brain just getting a fraction smarter each and every time. So let's just recap the entire thing. When you boil it all down, it really just comes down to these 5 basic steps. 1, you feed the digital brain a whole diet of prepared data. 2, it takes a guess, that's the forward pass. 3, you calculate how wrong that guess was using a loss function. 4, it traces the mistake back to the source with backpropagation. And the most important step, 5, it updates itself and does it all over again. Repeat, repeat, repeat. And that's really it. That's the elegant process that allows a machine to learn. It's not magic. It's just a cycle of making mistakes and correcting them over and over at an incredible scale. And that leaves us with one really powerful question. Now that we know how to teach a digital brain almost anything, what should we teach it next?